Yes. Good morning to all. Today I will demonstrate the design solar dryer design facility available at Rajiv Gandhi Memorial College of Engineering and Technology. What is the need of solar dryer? All are knows. Long run storage of product. In cold storage also we can make long run storage not more than 1 year. Why? Because damage of the product will start. Enzyme activity is increasing. And second, due to thermal shock, the post harvest losses are high if we are preferring cold storage. Thermal shock and transportation losses. The rough estimation is more than 30 percentage of the agriculture produce fruits and vegetables are damaging because of this thermal shock and transportation. For eliminating that one, solar drying is the best option. Means drying means removal of the moisture. We can store long run storage, maybe 4 to 5 years also we can store the product. But for the designing of the solar dryers in Andhra Pradesh, only one institute is available, that is Rajiv Gandhi Memorial College of Engineering and Technology. This entire lab is established, funded by DST, SERB, Science Engineering Research Board, and DST FIST. And now I will see the designing of solar dryers. First, whatever the product, which product we want to consider, we are analyzing the moisture. The first step in design of the dryers, the first step, analyzing the moisture of that product. What are them? Tomato, green chili. Why? Because tomato is not one type. Hundreds types of the tomatoes, green chilies, onions are available. For which product we want to design, first you select and analyze the moisture by using the moisture analyzer. This is the moisture analyzer. This is the heating coil, and the evaporation rate of the moisture also in laboratory level. And the sample maybe 10 grams, 20 grams of sample we are collecting. For that sample we are analyzing the moisture. First thing, how much moisture is there and on which temperatures the evaporator rate is there. Highest temperature we are setting 75 degrees, we are reducing 75 degrees. What is the evaporation rate, how much time it is taking? 70 degrees, 65 degrees, 60 degrees, 45 degrees, like that. Different temperatures we are measuring the evaporation rate. Once we know the evaporation rate, effective evaporation temperature without damage of the product, and how much moisture is there, these two we are measuring by using the moisture analyzer. This is the first step. The data is logged in data logger. Is a common DT85 we are using. For solar application generally we are using DT85 data logger. The main advantage is at 65 degrees temperature also data logger with minimum error it can log the data. That's the main advantage of this company, data logger, data taker. Next, once we know the temperature, effective evaporation temperature, then the removal of the moisture, artificial laboratory we set up. Why? Because the laboratory setup is available. I want to design the system not for Andhra Pradesh. Maybe my client in Gujarat, my client in Uttarakhand, or my client in Tamil Nadu. I want to create that atmospheric temperature in artificially. What is the relative humidity? What is the solar radiation is available? What is the ambient temperatures are there? So artificial ambient conditions we are creating in laboratory setup. This setup is available in Gujarat, I think Sardar Patel Renewable Energy Research Center. Then after in India, we are the only center available this artificial laboratory facility. Here you can see 3 trays for repeatability of the readings. The loading capacity maximum 100 grams to 200 grams. Loading capacity. And this is the solar dryer, the laboratory setup solar dryer. Here we are connected heater coils and load cell. We are measuring the relative humidity. You can see this is the relative humidity. Temperature and relative humidity we can set this much of temperature, this much of relative humidity of the air. Relative humidity is moisture content of the air. Why? Because different places, different moisture conditions are there. So initial temperatures and moisture conditions we are creating artificial. This is the data logger. We are logging the data. And next, what is the load? What is the flow rate of the air? Why? Because removal of the moisture means artificial flow rate of air is required. You can see for increasing the relative humidity by using pump, we are circulating water. This is the sump. From the sump, water is collecting the pump. You can see this is the humidified chambers also not common chamber. We created three separate chambers because I want to, at a time I want to do three different relative humidity means I can do my experiment three relative humidities, three input conditions. This is the sprinkler is available. So humid air, how much relative humidity is there according to our set point we can set input relative humidity. This is the blowers also we are not used common blower. Individual mass flow rate we can achieve by opening of these dampers. These three dampers is there. According to opening of the dampers, different mass flow rate of the air we can achieve. This is the flow rate measuring sensors. So three separate facility, different temperatures, different relative humidity. Here we placed heater coils. Heater coils we connected above the insulation. So three heater coils separately. So three different inlet temperatures, different relative humidity conditions, input conditions. We are testing the drying rate, how much time it is taking, what is the mass flow rate of the air is required, in which temperature is suitable. Based on the relative humidity, the temperatures are changing. The humidity rate, how the increasing of the humidity rate increasing. But because suppose in South India I want to test in the coastal region means inlet relative humidity is 60% to 70%. In Rayalaseema or Hyderabad, I want to establish dryer. The inlet relative humidity may be 30 to 40%. So entire size of the dryer is changing. According to product, size of the dryer is changing. So first we are analyzing entire thing before designing the dryer in the laboratory setup. You can see recently we established in October itself. This is the setup. Entire control system with control system and data logging unit. Then after I am showing one realistic development industrial dryer we developed funded by Science Engineering Research Board DST. Why? Because drying means we are removing bonded moisture and surface moisture. While removing our surface moisture, we want to exchange the air. But removal of the bonded moisture, creating the capillary action, at that time moisture is not air relativity is not increasing, same air we can use. So for that purpose we separated heating and drying process. In solar generally heating and drying is combined, but in our solar industrial setup heating and drying we separated. This is the heating unit. You can see ETC with heat pipe based collectors. This is not just ETC tubes. 5 collectors we connected in series. 1 meter cube per hour flow rate of fluid, at least 10 degrees temperature rise we can achieve. This is two layers we are using. So 5 collectors in parallel and 2 collectors in series. 2 rows in series, 5 collectors in parallel. So total mass flow rate we are achieving 1 meter cube per hour to 3 meter cube per hour according to our need and temperature rise. If we are not utilizing the for drying operation, directly this heat is stored in our storage tank. Once we are removing the bonded moisture, if you are removing surface moisture, then same heating the heat whatever absorbed in the heat transfer fluid, directly it is transferring in the dryer unit. So you see for wind resistance, direct grouting to the ground we did. So the alignment we will maintain proper alignment. This is the drain pipe. So I want to change the heat transfer fluid. Earlier first we selected thermal oil. Then after we selected because 80 to 90 degrees temperature means why not we can move to the water. We moved water also. Any type of the heat transfer fluid we can select. This is the connections. This is the outlet to the dryer cabin from the heater coil unit. And if dryer is not utilizing, directly it is going to the storage tank. This is the storage tank outlet and storage tank inlet. If solar is not coming, we will stop the supply to the storage tank and directly it will go to the dryer unit. You see, this is the ETC with heat pipe system, not just ETC collectors. ETC collector generally we are using water heating. For power generation, continuation with mass flow rate heat supply is required. This is the evaporation unit. This is the condenser unit. This condenser unit we are placing in manifold. You can see this is only the condenser unit is exposed to the heat transfer fluid. So entire tube, the heat transfer fluid is not running. This is the main advantage of the system. And with particular mass flow rate, we can generate the delta T. Generally, solar water treatment entire day it can generate maybe 100 liters, 200 liters water heating like that. But for industry application with mass flow rate, 10 degrees delta T is required, 20 degrees delta T is required. So for that purpose only this heat pipe based system introduced. So this heat pipe we are immersing in a manifold. Upon the condenser, the heat pipe condenser unit, heat transfer fluid is flowing. You can see. So we are collecting, even though these ETC tubes are failed, at that condition also our system is not stopped. Generally, solar water heater means one ETC tube is failed means total system will stop. Then whatever the heat is there, we are storing in the storage tank. According to dryer needs, we are supplying from the storage tank. This is the outlet inlet. This is the outlet of the storage tank and top side inlet of the storage tank. Two circulating pumps we placed like industry. One is buyback. If one is not working, we can run second circulating pump. You can see this is the blower unit. This is the suction from the ambient. If bonded moisture we are removing means from the dryer directly it is taking the suction. Otherwise it is taking from the ambient. Once we start the blower, you see suction and this compressed air we are sending in the dryer unit through the duct. Duct contains 50 glass wool insulation. So the heat loss, we are reducing the heat loss. This is the entire control board. We can change the speed, the mass flow rate of the air, entire duct. You see, this is the outlet of the duct. This is the inlet of the duct. It is going from the dryer. It is coming in this direction. This is dryer outlet and blower inlet. This one blower inlet. This one dryer outlet. If bonded moisture we are removing, simply we will close this inlet and outlet valves and we will open this damper. Automatically recirculation of the air will take place. Because of this operation, we are extending solar drying time. Earlier condition after 4 to 4 o'clock means max we are closing our drying. Now we can extend our drying 1 to 1.5 hour according to the product. So within the day we can complete our entire drying operation. This is the main advantage of the system. It is available at Rajiv Gandhi Memorial College of Engineering Technology, Nandyala, in Andhra Pradesh itself. So this is not one sample system I am showing. So according to customer need, I already shown that laboratory facility. We are generating data of particular condition where we want to install the dryer, and we are designing according to customer financial capability and dried product value, market value. Based on the dried product market value, we can design the system. This is only one sample system I am showing. We can design any type of system. This is the that from the blower directly it is coming to the drying unit. Here we are placing heat exchanger. In the heat exchanger, the hot fluid is circulating. This is the dryer unit. The conveyor belt system we placed for industry application purpose. After observe, you can see this is moving. This is the after drying, dried product we are collecting from sorry, from this direction. The dried product we are collecting from this direction. This is the outlet. I think for visualization we placed glass, but in camera it is not fully visualized. I will open this door, then we can see. So the movement of the conveyor belt you can see. So loading we are doing from the top. This is the heat exchanger. Through the heat exchanger pipes, heat transfer fluid is moving. Through the fins, the compressed air is entering inside the dryer. 20 to 30 degrees delta T, more than ambient we are generating inside the dryer cabin. Based on the product, it is not fixed. Suppose fish drying 10 to 15 is more than sufficient. Onion 30 to 40 degrees is sufficient. So product to product, type of the product also. In green chili itself we tested 4 to 5 types of the green chili. It is not matching one type to another type. Entire operation conditions are different. Some green chili skin thickness is high, some green chili skin thickness is low. So we can't fix it. This is the drying time, this is the mass flow rate of the air, or this is the temperature of the air, like that. After laboratory experiments only we can finalize what is the operating temperature of the air and flow rate of the air, how much drying time it will take. This is the loading, top side loading we are doing upon the conveyor belt. So after humid air through this duct, it is coming to blower. If relative humidity is high, we are exhaust to the environment. If relative humidity is low, then we are recycling the air. At that time we are storing the solar energy. The main advantage of this system, we are separating heating and drying. Generally solar dryers, heating and drying we are not separated. This is the duct, you can see. So this is entirely established in our lab only, or in our institute lab only. That's why you can see, uh, not in industry. Entire lab according to our convenience. We connected the pipeline connection. This is the outlet of the heat transfer fluid. This is the long view of the system. I think we are capable to design the system for any type of the product with the minimum charges. With minimum charges, designing, development, performance evolution, we will support. We will support for erection commissioning also. Then after training of the labor also we will support. Entire service we can made regarding solar dryer design development. You are anyone freely can contact Rajiv Gandhi Memorial College of Engineering and Technology. Thank you very much.